There was a time, and it wasn't all that long ago, when a pickup truck broke down on a back road somewhere in Tennessee and a man could fix it. Not a dealership, not a computer, not a software subscription. A man with basic tools, a replacement part from the Napa counter down the road, and 40 years of know-how built from trial and error. That time is ending. Not because trucks got better, because someone decided you shouldn't be able to fix them anymore. I want to talk about that today. Not because I'm angry, though I am, because I'm disappointed. And I've learned over 4 decades of turning wrenches that disappointment is a more honest emotion than anger. Anger makes noise. Disappointment just sits there and points at what went wrong. If you're new here, my name is Wade Tucker. I've been working on pickup trucks since before a lot of you were born. Diesel mechanic for 22 years. Retired now, but I still fix trucks every week because a man like me doesn't stop working just because he stops getting paid for it. I put engines in and pulled engines out of more pickups than I can count. F-150s, Silverados, Rams, Tacomas, Tundras, every generation from the ones your grandfathers drove to the ones sitting on new car lots right now. And I can tell you this with absolute certainty. The truck you can actually fix is disappearing. Not by accident, by design. Before I get into it, if you haven't subscribed yet, go ahead and do that. This channel is about keeping you independent of the people who want to take your money and your knowledge at the same time. Hit subscribe, stick around. There's plenty more where this came from. And while you're at it, leave me a comment at the end of this video. I read every single one. I want to know about your experience. More on that at the end. Now let's talk about what's happening. The modern pickup truck is built to fail. I don't mean fail the way any machine fails eventually. I mean fail on a schedule. I mean fail in a way that costs you money you didn't budget for, requires tools you don't own, and sends you down a road that leads to one place, the dealership service department, with your checkbook already open. There are 3 layers to this. 3 deliberate choices made by engineers sitting at desks, probably in Michigan or somewhere, who never once turned a wrench on the side of a road at 2 in the morning with a flashlight in their teeth. 3 layers that, when stacked together, mean the truck in your driveway right now may be the last one you can actually fix yourself. The first layer is electronics, specifically the diagnostic software that controls what your truck knows about itself and what you are allowed to know. Back in the day, if your truck ran rough, you pulled a spark plug wire, held it close to the block, and watched for spark. If you had spark, the problem was fuel or compression. You could chase it down with basic tools and maybe a repair manual from AutoZone. Those days are gone. Modern trucks have computers running everything, and the computers talk to diagnostic software that used to be available to anyone with a laptop and a willingness to learn. That changed. Ford runs something called FDRS, which stands for Ford Diagnostic and Repair System. It's their proprietary software that handles everything from basic code reading to module programming. GM uses GDS2, their global diagnostic system. These aren't secrets, but here's what is. Independent shops can't buy a legitimate license for this software. Individual owners can't buy it at all. Only dealerships have access. And when your check engine light comes on and your $50 code reader from Amazon tells you the code but not the cause, you have 2 choices. Drive to the dealership and pay whatever they ask, or guess. Neither one is acceptable. I had a 2015 F-150 come through my shop a few years back. Owner said the transmission was slipping. Dealership quoted him $4,200 for a full rebuild. He came to me because he'd seen my videos. I spent 2 hours with the truck, found a cracked vacuum line to the transmission modulator. Cost him $6 for a piece of hose and an hour of my time. He fixed it himself after I showed him where it was. That transmission went another 90,000 miles. But he couldn't have found that $6 fix without knowing how the system worked. And most people don't know. Because Ford doesn't want them to know. Because Ford makes money every time you can't fix your own truck. That's layer 1. Layer 2 is sealed components. This is the one that gets me the most because it's so obviously unnecessary and so obviously profitable. Take a transfer case. In an older truck, you opened a drain plug, let the fluid out, closed the drain plug, opened a fill plug, poured in new fluid. 15 minutes, $12 for the fluid. In a 2020 or newer Silverado or Sierra, the transfer case has no drain plug. None. General Motors made a deliberate engineering decision to seal the transfer case so you cannot change the fluid without special tools, a specific adapter that fits a proprietary fitting, and either factory service information or a YouTube video made by someone who figured it out before you. Why? What is the engineering rationale for eliminating a drain plug? I'll tell you what it is. The engineering rationale is that the fluid breaks down, the transfer case starts to wear, and when it fails, you replace the whole unit. A new transfer case for a 2020 Silverado runs $1,800 to $2,400 depending on the shop, plus labor, plus fluids. You're looking at $2,500 to $3,000 to fix something that would have cost you $12 and 15 minutes in 1995. The same thing applies to differentials. Many newer trucks come with differentials that have electronic torque managers, integrated sensors, and housings that are welded or press sealed rather than bolted. You can't get into them without cutting the housing open. When the gears wear, you don't rebuild. You replace the entire housing assembly. I've seen rear differentials on 2019 and newer trucks where the only repair option is a new unit from the dealer for $1,600 or more. And the fluid? If the manufacturer bothered to specify a service interval at all, it's buried in fine print that says use dealer equipment. Transmission units are the worst of this category. Modern automatic transmissions are sealed modules. The fluid is in there, and when it breaks down, which it will, the transmission starts to slip. The dealer solution is a transmission replacement or a very expensive flush that only their equipment can perform. In my experience, a properly maintained older transmission with fluid and filter changes every 60,000 miles will outlast the truck it's in. But on a newer truck, that service is either not recommended or physically impossible without dealer tooling. That's layer 2. Layer 3 is materials. This is where the weight savings people got carried away, and pickup trucks are paying the price. The 2017 model year brought us the all-aluminum body on the Ford F-150. Ford marketed it as revolutionary. Aluminum body, better fuel economy, same capability. What they didn't tell you is that aluminum dents easier than steel and requires completely different repair techniques when it does. A dent in a steel body panel can be pulled out with basic tools, some heat, and patience. A dent in an aluminum body requires aluminum-specific pull equipment, aluminum-specific welding knowledge, and in many cases panel replacement because aluminum work hardens when you try to reshape it. Most independent body shops don't have aluminum repair equipment. The ones that do charge significantly more than they would for the same steel repair. So when your 2018 F-150 picks up a dent in a parking lot, you're looking at a repair bill that would have been $400 on a 2012 and is now $1,200 or more. And your insurance rates reflect this. Ford did this for fuel economy numbers, not real-world fuel economy. EPA numbers that get the truck classified right so Ford can meet CAFE standards and sell more trucks. That's the real reason. And yes, I understand CAFE regulations are federal law. I'm not saying Ford broke the law. I'm saying the law created an incentive to cut weight at the expense of repairability, and Ford responded rationally to that incentive. Aluminum engine blocks in diesel applications are another story. I'm not going to pretend the 6.7-liter Power Stroke in the newer Super Duty trucks is a bad engine. It's not. But Ford went with a compacted graphite iron block for the 6.7, which is different from traditional cast iron. Some of the 6.0 and 6.4 Power Stroke engines before it had significant durability issues, and Ford's engineers have been climbing out of that hole ever since. The point isn't that modern diesels are bad. The point is that the materials choices being made for weight savings and emissions compliance are creating new failure modes that didn't exist before. Composite body panels and integrated bumper covers fall into this same category. When your bumper cover is made of polypropylene and it's integrated into the fender design so you can't replace just the fender or just the bumper, one moderate impact means replacing both. That didn't used to be the case. In a 1999 F-150, the front fender was bolted on. The bumper was bolted on. You could replace either one individually. Not anymore. Now everything is a subsystem, and subsystems cost more to replace than individual parts. This brings me to some specific examples from trucks on the road right now. The 2017 through current generation Ford F-150 with the aluminum body is a case study in repairability loss. I talked about the dent issue, but it goes further than that. The aluminum hood and fenders require aluminum-specific fasteners, aluminum-specific adhesives, and aluminum-specific corrosion treatment. If you live near the coast or in a state that salts roads in winter, the aluminum panels on these trucks develop corrosion patterns that steel panels wouldn't. Ford's solution is to coat the aluminum, which they did, but the coating is thin, and once it fails, you're dealing with galvanic corrosion between the aluminum and any steel fasteners or structural components it contacts. I've seen 2018 F-150s with significant corrosion on door sills and rocker panels at under 100,000 miles. In the older steel-bodied trucks, that would have taken twice as long to develop, if it developed at all. The Ram 1500 air suspension is the clearest example of designed-in failure in the half-ton truck segment. The air suspension system, which is optional on many trim levels, uses airbags in the rear to adjust ride height and load capacity. It's a useful feature if you regularly haul heavy loads or tow. The problem is the air compressor, the air lines, and the bag seals all fail within a predictable window. In my experience, and from what I've heard from other mechanics, the air suspension system on a Ram 1500 starts showing problems between 80,000 and 120,000 miles. The air compressor fails. The lines crack or leak at fittings. The bags themselves lose pressure. When this happens, the truck sits low in the rear, the system throws fault codes, and the ride quality becomes genuinely dangerous on rough roads. The repair cost is where it gets painful. A full air suspension replacement on a Ram 1500 runs between $1,500 and $2,500 at a decent independent shop. At a dealership, you're looking at the high end or beyond. And here's the part that really frosts me. The system cannot be rebuilt. Ford and GM use similar sealed strut assemblies in their magnetic ride control systems, but Ram's air suspension uses airbags that technically can be replaced individually. The compressor and the electronic control module, though, are proprietary units that require dealer-level programming to recalibrate after replacement. There is no aftermarket rebuild kit. There is no independent equivalent. You buy new from the dealer, or you find a junkyard part and hope it works. Compare that to a traditional steel spring suspension on a 1997 F-150, which I have personally rebuilt for under $400 in parts, including new shocks, leaf springs, and bushings. The 1997 suspension will outlast the truck if you maintain it. The Ram air suspension is designed to need replacement. That's not my opinion. That's what the failure data shows. General Motors trucks with the 8-speed and 10-speed automatics are another area of concern. The 8-speed Hydra-Matic used in Silverados and Sierras from 2015 onward is a decent transmission when maintained properly, but General Motors sealed the transmission fluid check and fill procedure behind requirements for their specific fluid, their specific fill level procedure, and their specific torque specifications. The dipstick was eliminated on many configurations. If you want to check your fluid level, you need to know the specific procedure for your model year, which includes engine temperature requirements, vehicle leveling requirements, and the correct fluid type. Most owners skip this entirely, and when the transmission starts to show signs of wear, the dealer recommendation is typically a fluid flush using GM specified equipment, which costs $300 to $500 at a dealership versus $80 for a DIY fluid drain and fill on an older truck with a dipstick. What does all of this mean for you as an owner? It means you are locked into dealer repairs for anything that involves electronics, locked into full component replacement for anything that involves sealed systems, locked into higher insurance and repair costs for anything involving the body and suspension, and most importantly, locked into a shorter ownership cycle because the economics of repair no longer make sense past a certain mileage. This is planned obsolescence built into the engineering, not through a secret memo that says, let's make these fail, through a series of rational engineering decisions made by people who answer to profit margins, quarterly earnings reports, and CAFE compliance officers. When you engineer to a cost target instead of engineering to a durability target, You get things like drain plugless transfer cases and aluminum body panels that cost more to repair than the truck is worth at 150,000 miles. It's not malice. It's the same kind of small, rational, individually defensible decision that, stacked together over 20 years, produces a truck that was never meant to be fixed. I want to be clear about something. I am not telling you not to buy a new truck if that's what you need. I'm telling you what you're buying. You're buying a truck that will require dealer service for electronic issues. You're buying a truck with components that will need expensive replacement instead of affordable repair. You're buying a truck that will likely be traded in or sold before it hits 150,000 miles, because the cost of keeping it running will exceed the value of the truck itself. That is the reality of the modern half-ton pickup truck market. Not because trucks got worse, technically, because the economics changed. Now, what do I do about it? I'm a simple man. I keep older trucks. My daily driver right now is a 2004 F-150 with the 5.4-liter 3-valve Triton. I know what you're thinking. The 5.4-liter 3-valve has cam phaser issues. I've heard the complaints, and I've also heard people driving these trucks past 250,000 miles because they understood the engine, maintained it properly, and addressed the phaser problem proactively when it showed up. My phaser started making noise at about 160,000 miles. I pulled the timing covers, replaced the phasers, the tensioners, and the chain. Cost me about $600 in parts and a weekend of my time. The truck has been solid since. That's what you can do with a truck built to be worked on. My backup truck is a 1997 F-150 with the 4.6-liter modular V8. Two-wheel drive, regular cab, long bed. The most boring, honest, reliable truck I've ever owned. I've had it for over a decade. I've rebuilt the transmission once. I've replaced the water pump twice. I've done suspension work, brake work, steering components, the whole thing. Total cost of ownership over 10 years, including the transmission rebuild, is less than $5,000. And that truck is worth more today than I paid for it. Try that with a 2020 F-150. I'm not a collector. I don't keep trucks because they're classic or because I have nostalgia for them. I keep them because they work. Because when something breaks, I can fix it in my driveway with tools I bought at a pawn shop and a parts manual from the internet. Because I own my truck, not the dealership. Because if I break down on a back road somewhere, I can diagnose the problem and I can fix it. And I don't need a laptop with $5,000 of proprietary software to tell me what's wrong. That's what I'm fighting for. Not the old trucks. The idea that you should be able to fix your own truck. The idea that what you own, you actually own. The idea that a truck is a tool, and a tool should be serviceable, maintainable, and worth maintaining. If you're driving a newer truck and you're watching this, I'm not trying to make you feel bad. I'm trying to make you aware. Know what you're dealing with. Learn your truck's specific failure points before they fail. Keep fluids changed on time. Watch your maintenance intervals. And when something does break, get a second opinion before you accept a $4,000 estimate from a service writer who went to a class on how to sell parts. If you're in the market for a used truck and you want something you can actually fix, look at the 1997 to 2003 model years. F-150s with the 4.6-liter or the early 5.4-liter. Silverados with the 5.3-liter Vortec. Tacomas if you can find a clean one. Rams with the 5.9-liter Magnum gas engine. These trucks were built before the sealed component era, before the aluminum body push, before the electronics got so deep that independent diagnostics became a joke. You can work on all of them. You can get parts for all of them. You can keep all of them running past 300,000 miles if you're willing to turn a wrench. The truck you can actually fix is still out there. You just have to know where to look. What's the most expensive repair you've had on a newer truck that you couldn't do yourself? Tell me about it in the comments. I read every single one, and some of the stories I hear from you are exactly why I keep making these videos. Leave your story down there. And if you found this useful, subscribe. There's a lot more where it came from.